Hi, my name is Richard Banks. I'm a principal consultant with Readify. Just want to give you a quick introduction to test-driven development. This is not going to go into a great amount of detail. It's more just to give you a taste of what it is, how it works, and how you might be able to apply it to your own situation. It is based around .NET technologies, but the principles still apply to everything else. Alright, now, unit testing. Hopefully we all understand what unit testing is. So this will be pretty quick, but for those who don't, unit testing is trying to prove that a single class is doing what you expect it to be doing, so that it behaves as expected, that the methods you call work successfully, that you handle error conditions correctly, and that it makes the appropriate calls to other classes when required. When you do test-driven development, you're actually taking this concept a little bit further. Instead of writing your code and then putting some unit tests on after the fact, we actually flip it on its head. What we do is we actually write our unit test first. So we write a unit test, watch that it fails because we run the test, then we add a little code to our application to try and make that work. If that works, all well and good, but if it doesn't, we run the test again, we add a little bit more code, rinse and repeat until we're done. Once we're done that, we add another test. Now, why is this good? Because we actually start thinking about our code from a quality and a testability perspective up front. We start thinking about what we're writing and why we're writing it. Instead of going, oh, I've got this requirement, I'll just start coding things up and then I'll add some tests. We say, well, okay, I've got this requirement. How can I write a test immediately to prove that it works? The advantage of that is you get a lot of quality built into your product from day one. You get massively high code coverage because all the code you write already has test for it. And you can be sure that you're not breaking anything else because you've got so many tests in your system. You can be sure that if you change a piece of code that you're not having side effects of that change break other code elsewhere. Alright, so how does it work? Let's just give you a quick demo of what's involved. So this here is some C# code, obviously, Visual Studio 2005, and I'm looking at a sample application that comes with NUnit. So NUnit is what we're going to be using for running our unit tests. We could use MS Test, we could use other unit testing tools, but here we're just going to use NUnit because it's the most common. What we have is, conceptually, we have this money bag container object. Basically, we put money objects into that container object, and from it we should be able to put in, say, $7 US, 28 Aussie dollars, 36 francs, all that sort of stuff, and pull out a total sum of money in a single currency. Easy enough. What I want to do is add to the money bag a facility that tells me what the last money item was that I added to the bag. So I need to write a test for that first up. So how am I going to do that? Well, I could do something like this. So I have a test. This test attribute here marks this as a unit test called last money added. And what I'm doing is I'm creating an array of money objects, so 26 francs and $7 US, adding them to a money bag, and then I'm calling the last money added method and going to compare that with $7 US. I've actually got that around the wrong way. Let me just quickly switch that. Okay, so I'm going to expect to get $7 US back out of this method. Now this method doesn't exist. I've got a compiler error. If I try compiling it, everything falls over. Alright, so obviously need to add something to my money bag. So if I go to the definition of the money bag object, I can see it implements the iMoney interface. Being a good little interface program, I want to add something to that iMoney interface. So what I'll do is I'll come in here, jump down to the end, and we will stick in the extra declaration. Okay, so we're adding another method called last money added. It returns an iMoney object. All well and good. So we've added a little bit of code. Now we compile. Now, interestingly, the thing that I notice is that even though I haven't had to look at what implements iMoney, I can tell by leaning on the compiler that I'm implementing the iMoney interface in not only the money bag object, but the money class itself. Probably don't want to be telling the money class that it has this ability to report the last money added to itself. Doesn't really make a lot of sense. So immediately I can tell this interface isn't the right place for it to be. So I'm just going to get rid of that there. And I'll go back to the money bag. Now what I could do is I could add an iMoneyBag interface and all that sort of thing and implement that, but to save time I'm just going to cheat, hope you'll forgive me, and add the method directly. Yes, I know it's naughty, but it's a demo, so you'll forgive me. Alright, so I come in here and put in my method, and for the moment I'm just going to return null just to make sure that I haven't broken anything else by accidentally having a typo or something like that. I compile that, and if I look at NUnit, it's now detected this last money added. So if I run my unit tests, that one fails, but if I run all my unit tests I can see that everything else is working, so that's all good. And I can see also that I was expecting $7 US to be returned, but I actually got nulls, obviously because I haven't implemented anything within the method. So let's go do that. Alright, so I need to have in here some kind of return value. Need to have a variable to store things in, so I'll jump up the top. I'm going to insert a little private variable, last added money, jump back down the bottom, and last added money. Alright, excellent. Quick compile, jump back to NUnit, run the test. It's still failing. Why? Don't know why. Because I haven't actually assigned the value. So we better jump up into wherever we're adding money objects into our bag and set a value. Now I know just from the code that this append money method gets called from all over the place, but this is where money items are added to the bag. So what I want to do is in here stick in an assignment, last added money, and again last added money, build that, all succeeds, jump to NUnit, run my unit tests, everything works. Now I haven't had to look at what calls last added money because I can rely on the fact that my unit tests are actually calling that and I've got good code coverage, everything's great. Now, reasonably simple concept? Hope so. Because that's all you have to do. Now, doing this kind of process, I must admit, test-driven development, the first time you do it feels really uncomfortable because of the thinking you have to do up front and because of the idea of writing a test before you've written code seems so foreign to many of us. The other thing you need to be aware of is that you'll probably need to take advantage of a technique called mocking. Mocking is basically creating stub objects so that we test the interaction of our class under test to other classes without actually testing those classes. So we're not doing integration testing, we're just testing interactions. It's a fundamental difference and it's actually really important so that we're testing classes in isolation. In order to do it effectively though, what you'll need to do is make sure that all your code is written with interfaces and things like that so that you can actually intercept the objects and use factories and things like dependency injection and inversion of control to get the objects you want, the mock objects, in place. So where I was calling iMoney objects, I could, if I wanted, put in mock iMoney objects in various tests and instead of testing an iMoney object is created properly, I'm just testing that the money bag interacts with an iMoney object, if that makes sense. Tools that you might want to look at in terms of doing mocking. RhinoMock is quite a good tool, as is NMock and EasyMock. There are other mock frameworks out there. You'll have to have a look at what's suitable for you. These ones in particular, obviously for .NET. The Java world there's a lot more out there, a lot more into it, but worth having a look. And just in summary, my name's Richard Banks. This presentation was part of the Readify Developer Network, and we look forward to seeing you in the future.